So good morning, everybody, and thanks for coming to AWS Migration Day, part of the 2019 edition of Postgres Conference. I'm Kevin Jernigan. I'm a product manager in the Amazon RDS team, focused on Postgres, both RDS for Postgres and Aurora Postgres. So at AWS, we really appreciate you spending time with us today. And for some of you, later this week, I know a lot of you will be staying for other parts of the conference. And we love events like this conference because it gives us the opportunity to talk with lots of customers in a short period of time. And we quickly can get very deep on customer requirements, especially for database workloads in AWS. As some of you may know, we spend most of our time building features for customers. About 95% of everything we release is based directly on customer requirements. So before I dive into the presentation, I want to get a sense of who's in the audience. So maybe you can tell me with a show of hands, how many of you are new to Postgres? Okay, we got a few people new to Postgres. How many of you are Oracle users? Okay, how many are SQL Server users? And how many use other commercial databases like DB2 or Sybase or databases like that? Great, so we've got a pretty good cross-section of database experience. So I'm going to just briefly review the schedule for today. It's all in this room today. And if you're wondering what we mean by migration, we mean migration from on-premises to AWS, and of course, more specifically, from commercial databases such as Oracle and SQL Server to Postgres, specifically RDS Postgres and Aurora Postgres, which are our managed Postgres services. So here's the schedule today. We start off with this session, which I'll give an overview of Amazon RDS and the two flavors of Postgres that are available in RDS. We'll then dive deep into Aurora Postgres and move from there to a focus on migration from commercial databases to Postgres, culminating in a session on Amazon.com's migration from Oracle to Aurora Postgres. And then we'll wrap up with an Ask Me Anything session about Postgres on AWS. But let's get started. So before we dive into Postgres, managed Postgres on AWS, I want to cover a little bit of history first, starting with me. So I've been with AWS just over 3 years, but I started my career 32 years ago at a small company called Oracle. Back in 1987, I was a product manager in the Oracle database team. Now, I stayed there for 4 years as the company grew from 800 to 8,000 people. But then I left and built a consulting business with some other ex-Oracle people in the 90s. And we mostly did work on data warehousing. But we did work on Oracle and Informix and IBM UDB EEE, which became IBM DB2 LUW and Sybase and et cetera. But then we sold the company and I started another business, a software as a service company built on top of Oracle in the year 2000. But 9 years later, when it was clear my business wasn't going to take over the world, I went back to Oracle. So in 2009, I started back at Oracle running a product management team in the Oracle database team focused on storage and performance-related features. And then late in 2015, I decided to leave Oracle and come to AWS. And so I've been at AWS ever since, but of course I made a big transition from being an Oracle expert for almost 30 years at that point into the world of Postgres. And just to put that all in context, some of you may have seen this graphic. This is from the Hasso-Plattner Institute, and this is a timeline of relational databases. And so it's way too detailed to put on one slide, but I just called out a few important database projects from the middle of this. And you can see Oracle way back in 1977. Postgres, that actually is the mid-'80s. Postgres started not as PostgreSQL, but just Postgres without the SQL part. And we'll talk more about that in a moment. It's fun to look up this graphic, though, and it's totally public domain. It's easy to find. And you can trace the history of all kinds of different relational database projects. So while I was trying to grow my SaaS business, in 2006, Amazon launched this service called AWS, initially with S3, SQS, and EC2. Simple, kind of basic services for providing storage and for just managing queuing and workflows and providing servers. And 3 years later, we launched Amazon Relational Database Service, or RDS, with support for MySQL. Then in 2012, we added Oracle and SQL Server. And in 2013, we started with Postgres, specifically Postgres 9.3. A couple years later, we launched Aurora with MySQL compatibility, and then a couple years after that, Aurora Postgres. And like as you saw, we're going to dive deep into Aurora Postgres in the next couple sessions after this one. So I won't talk too much about Aurora in this slide, in this session. I want to dive into what RDS is all about with some specific details for RDS Postgres and Aurora Postgres. But since the beginning of Amazon.com, way back in 1996, we've run some of the world's largest and busiest production relational databases. So we understand how expensive and complex it can be to manage those databases, to manage database administrative functions like patching and performance optimization and backup and recovery and disaster recovery and replications and failovers and all that. And it's tough to do that for constantly changing applications. And so adapting those operations to the cloud also requires different skills, new skills and new kinds of training. And so when you look at your deployment options for Postgres, the traditional way of running Postgres or really any database is on premises. And in AWS, you have a couple different options. You can run Postgres yourselves on EC2, so self-managed Postgres, or you can move it into the managed environments provided in RDS. Now let's take a quick look at what it means, what it looks like to run Postgres on EC2. So on EC2, you spin up a server, you attach some storage, you load whatever software you want, such as Postgres, and you have full access to the server and the OS and the database. You set those parameters. You have remote access. You can install third-party apps. You can install whatever extensions you want. But that means also you're responsible for all of that. You have full responsibility for managing upgrades and patching and backups, and for most responsibility for security of that environment. And if you want to set up HA and replication, it takes a lot of time and complexity, not just initially, but on an ongoing basis. So what if you could do all that in an automated way, reducing your costs and improving your availability and improving your performance? And so, what if you could have HA and DR that's done automatically for you? And with a single API call or a single click of the button, you could turn on HA and DR. This whole approach allows you to get the full advantage of enterprise-level capabilities for your databases, even if you're just a small startup. You don't need to hire a bunch of expensive, experienced staff. You can literally just click a few buttons and implement those features. And so that's why we created RDS. We really created RDS way back at the beginning because we had given customers those basic capabilities of servers and storage and some other services, and they asked us to make it easier to run databases. And so we started with MySQL, but then added these other engines you can see here. We technically think of it as 7 engines since we think of Aurora as 2 different engines. And so RDS automates the time-consuming administrative tasks such as hardware provisioning and database setup and patching and backups, while also providing cost-efficient and resizable capacity. It frees you up to focus on your applications, so you can give them better performance and HA and other capabilities without having to worry about all the details of the underpinnings. And so you can actually focus your people on the specifics that are unique to your business rather than doing the generic standard things that everybody has to do with databases. So I'm going to dive into a bunch of different things that you get with RDS. And the first thing is security. So we don't really consider security job 1, we consider it job 0. Security is a top priority for us and for customers. And so being able to secure your database environment is really important. We have a bunch of features in RDS that allow you to do that. First thing is security groups. So it's easy to install an RDS database instance and make it publicly accessible. You can use security groups to lock it down, but it's easy to make a misconfiguration, a configuration mistake that will expose your database to a wider audience than you want. And so, you probably don't want to actually make your database fully publicly accessible. So you can use security groups combined with virtual private cloud, with VPC, to really protect your database. VPC allows you to put your database in a private address space. It also allows you to carve out different subnets within your address space to further segment and isolate your application components, including your database. So when your database is launched inside of a VPC, you get to control which users and applications access that database and how they access it. Now, once it's running inside of VPC, you have lots of options to manage connectivity to that database. You can create a VPN connection from your corporate data center into that VPC. You can use Direct Connect to link your data centers to an AWS region to give you more consistent and lower latency connection to your VPC. You can peer two different VPCs together, allowing applications in one VPC to access your database in another VPC. You can grant public access to your database if you want to attach an internet gateway to your VPC. And you can control routing using route tables that you attach to each of the subnets in your VPC. So you've got lots of flexibility while still protecting access to your database. Now, another part of security, of course, is encryption. So we provide a key management service that manages keys for you. You can provide your own customer keys. And you could use default keys as an alternative. One of the problems with default keys is that will prevent you from sharing encrypted snapshots with other accounts. Now you might say, why would I want to do that? Well, a typical setup is you'll have a production account that manages your production databases, a production AWS account. But then you'll have separate AWS accounts for your dev test users because they shouldn't have the same privileges and they shouldn't have access to production resources. So you need to take a snapshot of your production database to share it with your dev users. But if your production database is encrypted and you're using the default keys, you won't be able to share it. You need to use your own customer managed keys. Then you can share those encrypted snapshots. And also, you should really use a separate key for each instance to really segment access so that if a key gets compromised, it limits the blast radius of a compromised key. And one other important thing, you can take an unencrypted RDS instance, RDS Postgres instance, take a snapshot of that instance, restore the snapshot into an encrypted instance. That's how you convert unencrypted to encrypted. And that's a pretty straightforward step. That's also a feature we just launched for Aurora Postgres about a week ago. So it's very easy to convert unencrypted to encrypted with your own KMS managed keys. Now let's go through some of these security features together. In this picture, we have an application, a set of applications attached or accessing a database instance. And you've got the snapshots or backups of the database, and you've got backups of the log files. Well, how do I secure all this? Well, I can start with a security group, as we discussed before, which I can protect access to my database instance. And I can use SSL so that the traffic from my host, my applications, to the database is encrypted. And then I can put it all inside a VPC, which is an even better way to secure the whole environment. And then I can enable encryption at rest, which encrypts the database storage, but also encrypts the backups and the backups of the log files. So it encrypts all the different types of data stored at rest for your instance. But what if, in the application, the user decides to try to set SSL mode to disable SSL? Well, that would allow them to access the database with an unsecure connection. So in RDS and Aurora, we allow you to force SSL to be on. So if you set the RDS.forceSSL parameter to 1, that will force all connections to use SSL. So if somebody tries to connect with SSL mode disabled, they will be blocked. They won't be able to connect. So you can really lock down your environment with all these different settings. Let's talk about IAM for a minute, Identity and Access Management. So there's a couple different things you can do with IAM and RDS and Aurora. First, you can use IAM to control who can do actions on your instances. Things like creating an instance or modifying it or rebooting it, deleting it. You can control that with IAM. Now, that's not a database user. This is not controlling access inside the database. We'll talk about that in a minute. This is controlling access this controls who can do what to your databases. You, of course, can set up database users. This is standard Postgres stuff to control who can access which tables and objects and schemas. But then we've also integrated both Aurora Postgres and RDS Postgres with IAM for authentication. So IAM Auth, as we call it for short, generates tokens, very secure tokens using AWS Signature version 4 that only have a 15-minute lifetime, so they get rotated frequently. It's really hard to break through the security of this approach. This is seamlessly integrated with both RDS Postgres and Aurora Postgres. So it's a fairly new feature for both of those services. And finally, something very recent that we added is support to restrict password changes on your Postgres instances. So this simplifies integration into third-party and homegrown password management tools, enabled with a simple parameter, and has the flexibility to assign roles to allow certain users to modify this policy. And one of the reasons customers are concerned with security is they have certain compliance requirements they have to meet. And we have lots of different customers in startup and enterprise and public sector spaces running a whole wide range of applications and workloads across lots of industries. And so some of those workloads require they meet certain regulatory requirements. Now, to support the audit and compliance requirements of these customers, we've worked to achieve certifications that you can run your workloads on RDS and be able to achieve a fully compliant application. And for RDS, we currently offer 9 compliance attestations, including SOC 1, 2, and 3, FedRAMP, PCI DSS, and HIPAA. Now, with these certifications, it means you can build and run your applications and workloads related to those compliance regimes on RDS. It does not relieve you of the responsibility of making sure your application meets the appropriate requirements. AWS takes responsibility for the compliance of the RDS service and the infrastructure related to it, and you, the customer, take care of the applications you built on top of AWS. So with this shared responsibility model, you can take the audit findings from your application and combine them with the appropriate attestations from AWS's third-party auditors and have a complete verification of compliance for your application running on AWS. So another feature in RDS is what we call parameter groups. It lets you set up custom parameters specific to your instance to set things such as force SSL or to preload specific Postgres extensions, turn on auditing, turn on huge pages, other features. It lets you create standard groups that you can then copy across multiple instances or multiple groups of instances. It avoids errors, it avoids configuration drift. And this is a standard feature of RDS for all of our services. In RDS Postgres, you just have a database parameter group. In Aurora Postgres, we have both instance parameter groups and cluster parameter groups. Because as you'll learn in Aurora, we support clusters where you can have multiple instances attached to the same database underneath. And so some of the parameters need to be cluster level that apply to all the instances. Some of the parameters can be different for each instance. So we have both instance level and cluster level parameter groups in Aurora. Now, in RDS in general, we support multiple EC2 instance types. And so you can see the main ones we support here. It starts with the T2 and T3 instance types. And those are smaller instance types. They have, as it says here, moderate networking capabilities. They go up to 8 vCPUs and 32 gigs of RAM. And they're good for smaller or variable workloads. They do support some level of bursting of CPU usage. And at the low end, the T2.micro is eligible for free tier. We give you a certain amount of free processing on the T2 micro on a monthly basis. General purpose M4, M5 instances have better networking performance. They, of course, as you can see, go a lot higher in the number of CPUs and the amount of memory. They're optimized for CPU. They're good for running CPU-intensive workloads. And then the R4s and R5s have twice as much memory per CPU as the M4, M5s. So they're optimized really for the biggest, heaviest weight database workloads. For workloads that do lots of database operations and might have lots of connections, high connection counts. So RDS Postgres runs on all these instance types. Aurora Postgres currently runs on R4 and R5. We are looking at adding support for smaller instance types in the T class. That's something that's coming soon. So for storage, in RDS Postgres, you have 2 choices for storage. One choice is what we call general purpose storage. It's a lower cost option. It's SSD storage. Has a maximum of 32 terabytes in size. And the IOPS available is determined by how much storage you allocate. And there are some burst capabilities. But if you need to guarantee a certain level of IOPS are available to your application, to your database, then you would choose provisioned IOPS storage, which is a higher cost, but gives you the ability to provision up to 40,000 IOPS for your database, which is pretty high level for most applications. Same as GP2 goes up to a maximum of 32 terabytes. Now that's RDS Postgres. As you learn a little later, Aurora Postgres runs on its own special Aurora storage system, which has totally different characteristics. And so you'll learn a lot more details about that later today. Let's talk about backups for a minute. So in RDS Postgres, we automatically take a daily backup of your entire instance. And you can control a lot of the parameters on how that's done. But basically, we do that daily backup. You can set up retention, so it'll be retained for up to 35 days. We'll also archive all your wall files for up to 35 days, so that you can do a point-in-time recovery to any point in time in your retention window. If you're running multi-AZ, and you'll learn about multi-AZ in a minute, then we'll keep multiple copies in each availability zone. And also, if you're running multi-AZ, the backup is taken from the standby, not from the primary. Now that's all RDS Postgres. Aurora Postgres is different because we totally control the storage layer, implemented special purpose for Aurora. We take automatic, continuous, incremental backups. There's no backup window, there's no performance impact. Same as RDS, you can have up to 35 days retention and point-in-time recovery within that 35-day window. But there's nothing to worry about scheduling or worry about when your backups are happening. They're always continuously happening. All right, let's go through some scenarios with availability and multi-AZ. So in RDS, we have this feature called multi-AZ, or multi-availability zone. Now in an AWS region, we will always have multiple availability zones. And you can think of an AZ like a data center. So, in the Northern Virginia region, some people call it US East 1, we have a bunch of AZs. I don't even know how many we have. But the idea is each AZ is a separate data center on a separate floodplain, a separate power network, but close enough together to do synchronous replication for most use cases. So the multi-AZ feature, when you enable it for RDS Postgres, initially you might be running with an application on top of a database in AZ1. When you enable it for RDS Postgres, we automatically make a full-size copy of your database in a separate AZ. And then we set up synchronous physical replication so that AZ, that secondary copy, always has all the changes in the primary as of transaction commit time. And so that just runs that way. You can run applications in AZ2 still connected to the primary in AZ1. And like I said, there's physical synchronous replication going on. Now, when that primary database fails, we automatically detect that. We promote the secondary to be the new primary. And then in DNS, we remap the CNAMEs so that the applications that are trying to connect to that endpoint keep trying to connect. Eventually, they'll get connected to the new primary. And then to make sure multi-AZ is still happening, once that AZ is recovered, we then start the replication in the other direction to make sure you still have that second copy in a separate AZ. Now, that's all kind of automatic, and transparent to the applications. Another form of replication that we support in RDS Postgres is read replicas. And customers use read replicas for a couple reasons, well, sort of three reasons. One is to relieve pressure on the master by offloading read traffic to the read replicas. Another is to get data closer to where customers are. You might have customers spread around the world. You have your master read-write database in one region, but you can have read replicas in other regions so that their read traffic for your customers will get lower latency. And a third use of read replicas is for disaster recovery, to have a replica in another region so that if your master fails in your primary region and you want to fail over, you'll have a replica in another region that's ready to go. So let's kind of walk through some of these steps. So first off, let's say you have an application running and it's attached to a primary and you have multi-AZ enabled, the picture we looked at a minute ago. Separate from that, you can set up asynchronous replication to hydrate multiple read replicas. And then you can route some of your read traffic to those read replicas to offload that traffic from the primary. That's all great. What happens if the primary fails? Well, the secondary will become the new primary and it will continue doing the replication. So it will continue to hydrate the read replicas. And your eventually consistent reads will still happen. And of course, it flips the replication around, and so now your writes are going to the new primary. If you want to do an upgrade, you can actually upgrade the read replicas independent from the primary. Remember, they're separate full-size copies. You can even have different parameter groups in those read replicas if you need to as part of the upgrade process. Now let's talk about cross-region replication, or cross-region replicas as a way of reducing latency. So in this picture, we've got a primary and a multi-AZ secondary and a read replica all in US East 1 in Northern Virginia. And let's say I want to have a read replica in Ireland, in EU West 1. Well, that's easy enough to do with RDS Postgres. You just set up that cross-region read replica. and point your application at that read replica. If you want to then start migrating, you can use that setup. You can turn off writes from the application in US East 1, wait for the last set of changes to get replicated over to EU West 1, and you can decide that, and you can break the replication and decide that you want to move your app to EU West 1 now, so you start up your application on that new read-write master. And then you can turn on multi-AZ there. And now you're done moving your application from one region to another with minimal downtime. So let's talk about upgrades for a minute. So as some of you know, the Postgres community is a very regular schedule of releasing new minors and new major versions. New major versions come out once a year, late in the year, September, October timeframe usually. New major versions are where the community adds new features. Minor versions are where the community fixes bugs. And they generally release a minor every quarter. Now we support minor version and major version upgrades. With minor version upgrades, you can actually enable automatic minor version upgrades so that we will automatically apply new minors in the maintenance window for your instance. You don't have to check that button. You can actually apply the minors on your own schedule if you want. But a minor version upgrade is pretty simple. We shut down your instance, replace the binaries, and restart the instance. Because that's all a minor version is. It's a new version of the Postgres binary that has bug fixes, security fixes in it. And so that's pretty straightforward. Major version upgrades are a bit more involved. When the Postgres community releases a new major version, they release a version of PG Upgrade that helps you upgrade from old majors to new. PG Upgrade has to go in and change things in your system catalog based upon the changes the community has made in the new major version. So there's some real downtime there where changes are being made to your database. Now, when we run major version upgrade for you, we don't do that automatically because we consider it too intrusive and there's a risk your application might not work correctly in the new major version, so we're not going to automatically upgrade your instance for major versions. What we recommend you do is take a snapshot of your production instance, restore it to a test instance, run the major version upgrade there, and then do application testing on that upgraded test instance to make sure that you aren't introducing functional problems or performance problems for that matter with the new version of Postgres. And so we recommend you do that before actually doing the upgrade. Now you can actually minimize downtime for these major version upgrades using Database Migration Service, or DMS. So let's say you have an application running against RDS Postgres 9.5 and you want to upgrade to RDS Postgres 10. Well, the first thing you do is you create a new instance, the RDS Postgres 10 instance. You use the schema conversion tool to copy the schema from the production instance to your new target instance. And then you start a replication instance of DMS. You connect it to the source and the target, and you select which parts of the source to replicate, to copy from the source to the target, maybe the entire database, so all the databases in the instance. And then you let DMS truncate whatever was there, which presumably is nothing in your target, and load the data from the source to the target. And then DMS can also do ongoing CDC, ongoing change data capture. So it will keep the two databases in sync indefinitely until you're ready to switch over, right? So it will keep the database, running this way, like I said, as long as you want. You don't have to migrate immediately. Notice that there's been no downtime so far. All these steps don't interfere with your production use. The only downtime is when you disconnect and reconnect. So this minimizes downtime even for a major version upgrade. This is all assuming you already did the testing I talked about in the previous slide, where you took a copy and upgraded it and tested your application to make sure it works. All right, so RDS Postgres specific support for minors. So we support all the latest minors of the major versions that are supported by the Postgres community. That includes 9.4.20, 9.5.15, 9.6.11, 10.6, and as of last week, we now support Postgres 11.1. So some of you who pay attention might know that 11.2 is the latest minor for Postgres, and we will be adding support for 11.2 very soon in the RDS Postgres environment. Along with the minors, we support lots of extensions from various open source efforts that build extensions for Postgres. We currently support more than 60 in the RDS Postgres environment, and we support almost as many in Aurora Postgres. We support all of the extensions from RDS Postgres and Aurora Postgres, except the ones related to outbound replication, a feature that's coming for Aurora Postgres but isn't here today. So we support almost all of the same things. You can see I crossed out the line that says Postgres 11 is available in preview because it's not in preview anymore, it's in production. We have a special preview environment for RDS where we make pre-release versions of Postgres available for testing. And so Postgres 11 was in that preview environment, but now it's GA. We do plan to make Postgres 12 available in that preview environment sometime before the community makes it GA. And the community, if it stays on schedule, Postgres 12 will go GA September, October. So our goal is sometime between now and then is to get Postgres 12 up in the preview environment so you can test your applications and your workloads in an RDS managed environment for Postgres 12. And just a graphical picture of the extensions we support in Postgres. Way back in 2013 when we launched RDS Postgres 9.3, we started with roughly 32 extensions. We actually try to add new extensions with every minor that we add. So we always are looking at extensions that our customers are asking for and evaluating which ones are the right ones to add in the next minor. And that email address is where we encourage you to send requests for specific extensions, ideally with your use cases, workload. Why do you need this extension? How are you using it? That really helps us figure out and prioritize which extensions to add in the next minor. And that's true for both. I know the email says RDS Postgres, but it's true for both RDS Postgres and Aurora Postgres. We'd love to get that kind of feedback. Now, a little more detail on the extensions supported. These are some of the new ones we've added support for in recent releases. For some of you, ORFCE might be really interesting. That is an implementation of some of the built-in packages in Oracle's PL/SQL. So when you install an Oracle database, they install a bunch of pre-built packages that you then write a bunch of other PL/SQL code that calls all these standard packages. If you're trying to convert all that PL/SQL into Postgres, it's nice that some of those built-in functions already exist in Postgres so you don't have to re-implement them yourselves. Or FCE gives you a lot of those built-in packages, the common ones that you're typically going to use in your own PL/SQL. Makes it much easier to convert your PL/SQL into PL/PG/SQL. And as a side note, I believe that SCT, the schema conversion tool from the database migration service, is now ORFCE aware. So it can automatically convert your PL/SQL and take advantage of the ORFCE built-in packages. Now, these are some of the extensions, a larger list of extensions supported in RDS Postgres that our customers use a lot. One that isn't directly listed on here that's probably the most popular is PostGIS for geospatial capabilities. But PG routing is on here, which enhances PostGIS in certain ways. But these are just some of the extensions that customers tell us they use a lot. I'll call out a couple others. PG Audit. Turn on PG Audit, it gives detailed auditing information for all the access and SQL statements being thrown at your database. WAL to JSON is one of those logical decoders where if you enable replication from RDS Postgres, you can use WAL to JSON to convert your WAL records, all the change records, into JSON format and then send them off to whatever tool you want to consume that JSON. PG Hint Plan works well together with a feature we've added to Aurora Postgres called Query Plan Management. Helps you put hints on your queries, control the execution plans of those queries. And LogFDW is an extension we wrote. It lets you run SQL statements on your log files, on your Postgres log files where diagnostic and error messages are. You can actually use LogFDW to run select statements on those log files. So it's one way to do log analytics from inside your running instance. All right, so let's talk a bit more about replication for a minute in RDS Postgres. There's really three kinds of replication that we can support. One is kind of purely at the logical SQL SQL level. You can do statement-based or trigger-based replication. That's fully supported in RDS Postgres. It's not the most efficient way, but it's sometimes the best way depending on what your needs are. We support standard Postgres logical replication at the engine level, both with replication slots and with the newer PG logical capability. This enables tools like DMS. Database Migration Service actually sits on top of replication slots. And also enables third-party tools that might use replication slots or PG logical. And then we've already talked about what we do down at the physical engine level to support read replicas and multi-AZ. So let's take a closer look at the logical replication support. To enable it, you set rds.logicalReplication to 1. And then users who have the right privileges, the RDS replication and RDS superuser role, can access those replication slots. We provide support for event triggers, and we now support native logical replication, PG logical, wall to JSON, and decoder raw. And this lets you set up things like you see in that diagram. You can create your own custom logical replication handler and process the changes that are being made to your database into almost any format you can think of and send it to almost any target you want. You can, of course, send those changes to another relational database. It doesn't even have to be RDS or Aurora. It can be an on-premise database if you want. You can send it to a NoSQL database. You can send it to an S3 bucket in a file. You can put it into a Kinesis stream and consume that stream somewhere else. So you have lots of things you can do with the capabilities that we support in RDS for logical replication. I want to change gears a little bit and talk about monitoring. So with Aurora Postgres, we launched a new feature called Performance Insights. And we've since added support for Performance Insights to RDS Postgres versions 10 and 11 and to other RDS engines. So it's not limited to Postgres at all. We just started with Aurora Postgres. Performance Insights gives you a view of the load that's running on your database based upon the SQL statements. So it will sort those SQL statements by load, show you the wait states those statements are waiting in. It'll help you identify the top SQL, the ones that are generating the most load, so you can focus your tuning efforts in the right places. Works well with other tools like query plan management from Aurora Postgres and PG stat statements. It also allows you to pull the data out in an API. So you don't have to use the graphical user interface, the GUI that we provide. You can pull the data out and consume it in other ways as well. In addition to Performance Insights, we also provide a tool called Enhanced Monitoring. Now, Enhanced Monitoring gives you, as it says, more than 50 different OS level stats about what's happening on your database instance. I didn't really call this out directly, but in RDS and Aurora, you can't log into the host and run your own commands top and vmstat and all that. So we provide those same stats for you through Enhanced Monitoring. You can set up Enhanced Monitoring to give you granularity down to 1 second granularity if you need to. And all that data is also available through CloudWatch. So CloudWatch is another AWS service. It lets you graph various metrics. It lets you set alarms on those metrics. So if you want, you can set an alarm saying that, well, if the CPU usage on my RDS instance goes above 80%, I want you to fire off this alarm, which rings my pager. Or you can automate things. We have some customers who will set an alarm to cause their database to automatically scale up if the CPU gets above a certain level. So they'll do a scale compute, as we call it, which means that it's literally just an API call. You say, well, I want you to change the instance on this RDS database from this size to this size. And so some customers automate all that just by putting alarms on CloudWatch. And CloudWatch data, of course, can be pulled out through APIs as well. We also recently added a feature to RDS Postgres where you can automatically upload your CloudWatch, your Postgres logs to CloudWatch. So those Postgres log files that I mentioned before, you can use logFTW to access them in a running instance. You can also now have your RDS Postgres log files automatically flow into CloudWatch and then automatically flow into an S3 bucket. And lots of customers want to put all the log files for all their different application components into one bucket and then do log analytics on the whole pile. This now allows you to include your Postgres logs into that kind of setup. We are working on the same feature for Aurora Postgres. That's going to come soon. So I want to just kind of review quick tips based upon what we've covered. And most of these apply to both RDS Postgres and Aurora Postgres. And the first is for production applications, we always recommend you use multi-AZ for high availability to make sure that you have resiliency across lots of different failure cases. As you'll learn in Aurora Postgres, we have multi-AZ. It's done in a slightly different way, has some interesting benefits. But we'll dive into that in the next couple sessions. We also recommend that you use the automated backups that are available with RDS. And typically we like to see customers keep at least 3 weeks of backups around. Just covers you against various failure cases, because you can do point-in-time recovery across that entire range. We also recommend you actually do test your restores. Not necessarily because there'll be bugs in our backups, but there might be bugs in your process for doing restores. It's all about your people having the right playbooks and the right training and the right familiarity, because when you have to do a restore under pressure because you have something's burning down in your data center or in your running instances, you don't want to be doing it for the first time in months. So it makes sense to always practice restores. You should probably take periodical logical exports, dumps of subsets of your database, maybe certain schemas or certain tables. You might need to be doing more precise restores than entire point-in-time restore your entire database. So it makes sense in a lot of cases to take periodic logical exports as well. I don't see why you wouldn't force SSL. You should probably turn on force SSL in all your environments just to make them more secure. Strongly encourage you to think about enabling auto minor version upgrades so that we will be able to automatically apply patches and security fixes from the community when they're available, rather than you remembering to do it at some point. So I know some environments you need to schedule downtime very carefully, so you might not want to enable it. This is a recommendation, obviously not a requirement. You should also make sure that you follow upgrades for your extensions as well, because each extension has its own schedule. They're not done by the community, they each have their own little community. So they all have their own schedules for upgrades and enhancements. You really should enable performance insights. It's a free feature. It doesn't cost anything to turn on performance insights in your environments. By default, it will maintain 7 days of single-second granularity data of your running instance, so you can go back in time and see what was generating the load 4 days ago at 1:30 p.m. You can actually ask us to keep more data than one week, and there's a nominal charge for the storage. We'll keep data for up to 1 or 2 years of performance insights. But again, the initial level, there's no additional charge. You should really turn on enhanced monitoring, at least for 10-second granularity, if not finer. These are all really useful tools for keeping track. Okay, I'll take your question, yeah. You can choose specific versions. It depends on the version of Postgres. So there's some dependencies there. We can talk afterwards, because there's a bunch of experts in the room. We can talk about specific extensions and versions. You should enable PG stat statements. Works well with performance insights. Helps you just see more deeply into what's going on with the SQL statements in your instance. And you should look at putting alarms on things like transaction IDs. I didn't get into the guts of how Postgres works, and you can find out a lot in the next 5 days about transaction IDs and vacuum. But one of the risks is if you're not monitoring how you're using transaction IDs, you can run out of transaction IDs. Running out of transaction IDs is a really bad thing in Postgres. It can render your database unusable. We have some automation in RDS that monitors transaction IDs to warn you that you're going to run out, that you're heading to a bad place, and we try to help you avoid that. But you should really learn about transaction IDs, make sure you know how to avoid running out of transaction IDs. You should, of course, configure alarms on things like database load and free space, free disk space, and memory and swap usage, just in general, so that you know when you're getting close to any limits in your setup. Now, one thing to note about free disk space, in RDS Postgres, you need a pre-provisioned storage for your database, either GP2 or provisioned IAP storage, but you have to pre-provision it. And then you start putting data in and you start filling up that storage. That's why we say you should configure alarms on monitoring free disk space, because when you run out of space, then you have a problem. So you don't want to run out of space. You want to see when you're getting close and add more storage. In Aurora, we automatically grow the storage for you. There's no pre-provisioning of storage. It just automatically grows as you insert rows, all the way up to 64 terabytes. So there's less of a need to monitor for free disk space in Aurora. And again, you'll learn more about that later today. So there's a few forums that we maintain for getting more information about RDS and Aurora and EC2, and of course there's forums for all the other AWS services as well. So I'm just listing these three here. But it's really useful to go into these forums and post questions, because often other AWS customers will answer. And of course, we always monitor the forums and answer questions as well as part of the service teams. But these are great places to get information. So I've listed a few RDS Postgres customers here. Just want to cover a little details on how they're using RDS and some of the benefits. So most of you are probably familiar with Instacart. They provide a way to order same-day groceries online. And to avoid the complexities of building a new production database from scratch, they actually turned to us to use RDS for Postgres instead of self-managed Postgres. Now this allows them to add millions of new products and items to their database every month without having to focus their engineering team on all the block and tackle of just running databases. So they really see that they're getting a lot of benefits from focusing their engineers pretty much entirely on improving their application experience for their customers and not worrying about managing the database. Infor is one of the largest ERP application providers out there. They generally focus on building applications for specific industries. Unlike the traditional providers, primarily SAP and Oracle, they have a SaaS model based entirely in the cloud. And by using AWS and RDS Postgres and Aurora Postgres, they're able to quickly deploy their apps in the cloud across a wide range of industries and a wide range of applications. And then Vessel's a startup based in San Francisco. They provide their online subscribers early access to some of the best web series, music videos, and TV segments across multiple devices. Now, they built and launched their video platform entirely on AWS, and by using AWS and RDS Postgres. It's pretty much the same story. They can focus their time and resources on optimizing their applications and the experience for their customers. And then finally, I'll talk a little bit about Wave. And we really have a quote from Wave. Wave helps users locate their contacts on a private map. And they like to say there's a new wave, as they call it, opened every second. And I have a quote from their CTO. He says, "We found AWS to be the best way to achieve a vast, scalable pool of resources that can be triggered on demand with that kind of flexibility. We were looking for the same pay-as-you-go, maintenance-free experience for our databases, and Amazon RDS was the solution. It simplifies database maintenance, setup, and optimization, handles the heavy lifting by automatically managing connections, backup, security, and updates. Also, with multi-AZ, we can make changes with no downtime whatsoever." So obviously, the CTO of Wave is pretty excited about what they're getting from RDS. Now, I'm going to cover just one slide on Aurora Postgres, because we're going to go much deeper later, actually in the next session. Aurora Postgres, we built Aurora because customers were running RDS and using RDS to run databases from other people, from other companies, right? Or other projects. We were basically running other people's databases in RDS. Customers were seeing, MySQL and Postgres and Oracle and SQL Server, and they started asking us for the combination of capabilities between some of the enterprise database features they liked and the simplicity and low cost of open source. And so that caused us to build Aurora. Now, the core innovation of Aurora is to separate the logging and storage layer from the other layers of the database engine. And we've re-implemented the logging and storage layers. And that's what we call Aurora Storage. Aurora Storage maintains 6 copies across 3 availability zones of all your data. And it does that by, what we did was change the engine, the database engine, so that when you write a log record, we actually write it to 6 places, asynchronously in parallel, and we wait for 4 responses. And you'll learn a little later why 4 is the right number, 4 out of 6. And so we write log records to the storage nodes. And we have also changed the engine so we don't write dirty database pages. So we reduced a bunch of I/O out of the system. We pushed down a bunch of database work into the storage nodes because the storage nodes are very database aware. They take the log records and they apply them to database pages down in storage. That storage system will have hundreds or sometimes thousands of storage nodes in a single Aurora storage volume spread across those 3 AZs. So with lots of IOPS available, lots of processing available down in that storage system. So we've offloaded a bunch of work off the database nodes down into the storage nodes, which is how we deliver 3 times more throughput than standard Postgres. In some cases, customers have told us they see up to 11 times more throughput. It's very much workload dependent. So there's lots of cool stuff we're doing with Aurora because we fully control that storage layer. And again, you'll learn more about it later. We launched Aurora Postgres with support for Postgres 9.6. We've added Postgres 10 support. We will soon add support for Postgres 11. So that's coming a little bit later this year. And finally, taking a big step back, what's the bigger environment all this lives in? So RDS is in the box up there where you can see the engines we support in RDS, but we support a lot of non-relational database services as well. Dynamo, Elasticache, Neptune, DocumentDB, a Mongo compatible service we launched recently as well. So there's a bunch of other database services we offer to our customers because we know lots of customers want to use the right tool for the right job. And so sometimes they need to do graph processing or they need to do caching with Redis or Memcached compliant. So, there's lots of different services we're making available just because customers keep asking us for these things. So that's all I have time for. I appreciate your time. I'm happy to take a couple questions. Our next session is going to start in 8 minutes, though. So, yes. Yeah. So the question is, why do we have a constraint of 64 terabytes for Aurora as the size? There is no real constraint other than we just haven't had a lot of customers ask for more. That was what I used to say to that question a couple of years ago. We've had more customers ask, and we are going to increase that limit. So, but there's no hard technical limit other than not that many people asked for it yet. I mean, there is a limit. We have to do testing and validation and all that, right? Right. Other questions? Yeah.
Any feature parity between RDS and Aurora? I'm just kind of trying to rationalize in my head where they converge or where do they separate?
Right. So the question is about feature parity between RDS and Aurora, where they converge, where they diverge. So Aurora itself is built by taking the Postgres open source code and changing it to interface with the Aurora storage system. But that means that's down to kind of the lowest layers that you generally won't see as an application developer or as a user. So the behavior above that is mostly identical because it's mostly the same code. Now, having said that, we are starting to add things in the upper layers, like Query Plan Manager, QPM. Now, QPM is something specific to Aurora Postgres because we had to build it into the Aurora Postgres environment that isn't available in RDS or standard Postgres, but you don't have to use it. So technically in Aurora Postgres, it's kind of like Postgres plus things. So you'll see us continue to do that, add things to Aurora Postgres that may not exist in standard Postgres. Having said that, there are a bunch of things we're looking at that we want to contribute back to the community because we want to see them get into mainline Postgres, not just RDS, but anybody's Postgres. So there are some optimizations we're working on in query optimization, for example, that will work with the community. But of course, the soonest we'll get anything new is Postgres 13. Postgres 12 is done functionally. They're just pushing through the process to get it out. So we'll release stuff in Aurora Postgres that won't get into the community for a while. And so you'll see Aurora always be a bit ahead because it takes a while to get back through the process. Yep.
Thank you.
Yep.
Are there any plans for Aurora to add transparent data encryption rather than just storage?
Right. So the question is, are there plans to add TDE, transparent data encryption? Are you referring to column level encryption?
No, not that one. But like Oracle and SQL Server have transparent data encryption, so the data is encrypted at rest, not just at this volume encryption.
Well, so the encryption at rest we have, how is that different from the data encryption for Oracle and SQL Server?
Is that like Linux for volume encryption?
No, it's our encryption implemented. Sorry, it's encryption implemented at the storage level by us. But so it's conceptually the same. The part that's different for TDE and Oracle and SQL Server, you can actually do transparent column encryption as well. And that's why I was asking if you're talking about column encryption, because the encryption at rest in RDS and Aurora is functionally the same as encryption at rest that you see from TDE and Oracle and SQL Server, all right? But it's the column level stuff that's different. We don't yet have transparent column level encryption. So in RDS and Aurora, we support an extension called PG Crypto, which lets you encrypt columns, but you have to change your application. It has to be aware of the encryption, right? And TDE, full TDE allows you to encrypt columns without the application knowing about it either. So that's the difference. But maybe we can talk afterwards if that doesn't fully answer your question.
So does Aurora currently implement the non-PG crypto mode, or you don't have to make application?
No.
It's basically TDE now?
Yeah, we do not have TDE for column level.
Okay.
We do for the entire storage volume.
Is that on the roadmap? Should we offer that?
We've been talking about it. We should talk more offline. Yeah. Yeah.
I was wondering, we have a lot of legacy code that's been around for a long time. We have to use PLR, PL Perl, PL Python.
Right.
How does Aurora handle that type of stuff as you're migrating over from on-premise?
Right. So one of the challenges, a lot of those extensions are what are called unsecure or unsafe or untrusted because they allow you to run arbitrary code on the host, which would then allow you to do arbitrary things to the host. Not that you'd want to necessarily, but somebody might someday. And so it creates security holes that we can't afford to open up in the RDS or Aurora infrastructure. So the challenge there is, figuring out how to convert those to things that are supported and are safe and trusted in our environments. We have SCT that helps convert some things, but I don't think right now SCT supports those kinds of languages and converting them to other, like into PLPG-SQL or PLV8, which we do support. So that's more of a manual process at this point, if you really have a big, installed base of code like that.
So we would be kind of forced to do our own instances.
You would, if you didn't want to change any of that code, you'd run self-managed Postgres on EC2. Yeah, I mean, if you have that a bunch of legacy code that runs in extensions that can't be supported in RDS, then you have to do something if you want to get to RDS or Aurora. My answer is the same for RDS and Aurora. They aren't any different. They both have the same, approach to handling extensions. Yep. Any other questions? I think we should probably let the next presenter set up, because he only has 2 minutes to set up himself. But thank you for your questions. I'll be around all day so we can keep talking.